So in this lesson, I'm going to talk about capacitors. But I want this lesson to be more of a prequel to all the theory and mathematical formulas. So the very first time I heard this word capacitor was when I was watching this movie called Back to the Future. And in this movie we have this crazy genius scientist who has an idea that I want to travel back in time, and for that he invents a time machine. But for his time machine to work, he actually invents another device which is called flux capacitor. Even though in the movie the flux capacitor does what it's supposed to do, but in real life flux capacitors are pure science fiction. However, capacitors are very real devices. Capacitors are real. And their concept is so important and fundamental that Mother Nature itself has some processes that actually shows the concept of capacitor being applied. Moreover, most of the modern day technology has capacitors as one of its fundamental building blocks. So modern technology also have capacitors in them. Other things our modern technology has are resistors, inductors, transistors, etc. I call them the Tor family because all of them has like Tors at the end. Okay, so now I want to show you some analogies that will enable us better understand the concept of capacitors. So what's coming up next is analogies. So for our first analogy, I would ask you to remember your birthday parties. And one of the things that I remember from my birthday parties are the balloons and cakes and presents, all that neat stuff. But for the purpose of this lesson, I want you to concentrate on just the balloons. So think about a balloon. The ones that we have at birthday parties are probably inflated ones. But when you buy them from from some shop, you basically get a deflated balloon, right? It's just a piece of rubber, and then you have to just second thing you have to do is you have to pump some fluid into it. Pump fluid into the balloon, and that fluid could be air, it could be water, it could be helium if you want to make them float in air. Okay, so the second thing, you pump some fluid into it and the balloon starts to inflate. So I would say inflation happens when you are pumping air or any fluid into the balloon. And number 4 thing you do is basically you tie the knot at the end of the balloon right here, the opening end where you were putting air in it. You tie the knot here because you don't want the balloon to deflate again, because as soon as you leave this end of the open end of the balloon, the air will start rushing out, or any fluid will start rushing out. So basically these are the 4 things that actually you do. It's like a process. Number 1, you get a deflated balloon. Number 2, you start pumping fluid in it. Number 3, the balloon starts to inflate and it starts to blow up. And then number 4 is you stop. You don't want to really burst the balloon, so you stop and you actually tie the knots because you want to keep the fluid in the balloon. Okay, that's for it for this analogy. So for our second analogy, I would like you to imagine a spring. So let's suppose that we have a spring and we stand it vertically on some surface. This is some surface, and then this is our spring. And I want you to apply force on this spring vertically downwards, right? So the very first thing is that the spring is in its stationary position, nothing happened, so spring is there is an initial state of the spring, initial state where the spring is not compressed, it is what it is, just standing there. The second thing you do is you apply force on the spring, force on the spring. So what happens is that as soon as you apply force on the spring downwards, the spring will start to compress. So the spring compresses, right? And then the fourth thing you do is you keep the force. If you want the spring to be completely compressed, you keep the force, you keep applying the force till the spring is fully compressed. So you stop when the spring is fully compressed. So basically, if you let go, now the spring will pop back up. So it's also a four-step process. State number one was that spring is standing there, nothing is happening, you're not applying any force. State number two is basically you start applying force vertically on the spring from the top. Number three, as a reaction to your force, the spring starts getting compressed. And number four is that when the spring is fully compressed, you stop, and if you want to keep the spring at the same spot, you keep your finger on it. But as soon as you remove your finger, the spring will pop back up and it won't be compressed anymore. So that's the same 4 points that believe it or not, but if you can just go back to the just rewind back, and you will see that in the case of our balloon analogy and the spring analogy, these 4 points are very similar to each other. So now we're gonna relate these two analogies with the concept of a capacitor.